This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. We're going to solve this multiple angle trig equation in this video. Find all real numbers in the interval 0 to 2 pi that satisfy this equation. Cotangent of 3x plus 1 equals 0. So we're not looking for x in degrees, we're looking for x in radians or real numbers. All right, so the first thing we do is we solve for the cotangent. So we have the cotangent of 3x equals -1. So 3x is the real number we're looking for. We're trying to find in radians. Where will I get a cotangent of -1? Well, the cotangent and the tangent are negative in quadrants 2 and 4. But you really only have to find it in quadrant 2. Right, so that would be right here. Because if this is -1 and that's 1, that would be at 3 pi over 4. Because we know that the period of the cotangent and the tangent function is pi, so we know we're going to get another one by adding pi. So if you add pi to this, you could also get this other one, which happens to be 7 pi over 4. Now, if you think in terms of degrees, you can always first think of it in terms of degrees, but then your answer, remember, you want to write in radians. But that's not what x equals. That's what 3x equals, right? So 3x is equal to 3 pi over 4. And instead of writing this as 3 pi over 4 plus 2 pi k, or 7 pi over 4 plus 2 pi k, remember, since they're just pi units apart, because the period of tangent is just pi, you simply add pi k to get all the possible solutions where k is an integer. So this tells us what 3x equals. We're trying to find out what x equals. So I need to divide everything by 3, or you could do it by multiplying everything by 1/3, which actually is a little bit easier because you won't have this complex fraction. So for instance, you could just say, oh, divide by 3, divide by 3, divide by 3, but we have this complex fraction here, which is okay. But I'm just going to show you an alternate way of dividing by 3 is, of course, multiplying by 1/3. So I could say multiply by 1/3, multiply by 1/3, multiply by 1/3, and then we don't have a complex fraction. So this says x equals pi over 4 plus, what's over here? Pi k over 3. So if I wanted to find my solutions in the range from 0 to 2 pi, my first one I can see is going to be pi over 4. And then my second one I'll add, well, first when k is 1, I'll add pi over 3. Notice I don't have a common denominator. So it's going to be easier to write both of these terms with a common denominator, and that would be 12ths, okay? So actually, if I would have not canceled the 3's here, where I had the 1/3 of 3 pi over 4, I'd have it. There's your 3 pi over 12 right there. And for the second one, I'm going to have to multiply by 4 over 4, so that will give me 4 pi k over 12. Okay? Now, this would be all solutions, right? But we're only asked to give the solutions in the interval 0 to 2 pi. So the first one is pi over 4, or we can write it as 3 pi over 12. To make things simple, I'm just going to write them all with a common denominator. Later, we could simplify it. Now, what would the next one be? I would add 4 pi over 12. So that will give me 7 pi over 12. Now, as you're doing this, you have to think, is that still less than 2 pi? And it is. If not, you couldn't use it. So I'm going to add another 4 pi over 12. That's 11 pi over 12. Still under 2 pi. Add 4 pi over 12 again. That's 15 pi over 12. still under 2 pi. 19 pi over 12, still under 2 pi. And the reason, by the way, I know that is because that's 19 twelfths. That's like, 1 and 7 twelfths times pi, right? It's less than 2 pi. Now, if I add one more to it, what happens here? I have 23. 23 over 12 is still less than 2, right? So 23 over 12 is good. But if I add it one more time to the numerator, the 4 pi, I'm going to have 27 twelfths. That's going to be bigger than 2 pi. So these are the only solutions that are in that range 0 to 2 pi. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.